Thanks very much to Camilla, and thanks for those kind words. It's always nice when you get to write a little bit of your own introductory speech. Well, maybe not. I need to make a few housekeeping comments about the day and what we'll be up to, and then I'll deliver my address. There's good news. The good news is right behind David Lubinsky at the back of the room, there are Cokes and water and nuts. But there's even better news. I have good news and more good news. The more good news is that right behind this room, right behind the rotunda, in room 313, there's lots of snacks and more drinks and coffee and iced tea and hot tea and a bigger display of all sorts of things. So feel free anytime you need to head that direction. Restrooms are out in that hall and so on. We'll be moving along and we take a break in a little while, but do what you need to do to make yourself comfortable and happy, and we will move through the day. So let me now introduce our first speaker. Well, it is I and I am he, and the title of my talk is Teaching Undergraduate Statistics as Though It Really Matters. This is a talk that I've been writing in my head for many, many years, and I will very much look forward to giving it. It's the first time I've given this talk. I'd welcome, of course, scrutiny and discussion and conversation. I hope there will be a little bit of time at the end. It's a fairly short talk. Hope there will be a little bit of time for Q&A, and then we'll move on to Chip and others who will be the next presenters. Let me frame the problem. The problem as I perceive it is that the content of undergraduate and intro graduate, for that matter, statistics courses, the curriculum that we deliver, has hardly changed since the mid-1900s. Our courses focus on basic descriptive statistics. These days we call those exploratory methods rather than descriptive statistics, but they've changed only slightly. On probability theory, on sampling distributions, and the logic of null hypothesis significance testing. On the other hand, the discipline in which we are embedded, the discipline that we participate in, quantitative methods, has changed radically, substantially, in many different ways. We're all aware that methods that had not even been imagined in the 1950s are now common, and we teach those throughout our curriculum. Methods like structural equation modeling, multi-level modeling, item response theory, hazards modeling, categorical data analysis, to name a few. And so there are two conflicting perspectives of whether this really is a problem or not. I referred to it as a problem, but you might disagree, and you might very properly disagree. I don't suggest that I'm right and anyone else is wrong about this. I suggest that there are two legitimate perspectives. The first is that the introductory material should not change, that it is the foundation of our psychological science. And though the complexity of our sophisticated methods has advanced, one might say a sampling distribution is still a sampling distribution, a p-value is still a p-value, and alpha is still alpha. That's one perspective. Contrast that with the second perspective, that the introductory material should be changing as these sophisticated methods themselves, for which they represent an underpinning, change as well. And so this perspective would argue that as statistical modeling has advanced, so has much of the foundation. Power, p-values, Bayesian thinking, and so on inform what we do. And therefore, at the least, we should have become better at teaching foundational material. Now, watch carefully. I'm using a PowerPoint innovation here. Watch carefully. Okay, so you know what my perspective is. You know what I think. I think the introductory material at least should have been keeping up with the advances in the field. And so that brings me to two more conflicting perspectives. If you agree with me, and you may not, and I grant that this is arguable, but if you agree with me that the intro statistics curriculum should be changing along with the field, then the question, the new dialectic is, should it be changes at the detail level? That is, should we sharpen how we talk about power and p-values? Introduce a few new graphical methods like box plots and stem and leaf diagrams, but let the organizing structure stay approximately the same. Or alternatively, and again, a contrasting perspective, should we introduce fundamental and philosophical changes in how we teach introductory statistics? Should we reframe the whole field of statistics as we engage it as pedagogy? Should we move, for example, NHST into the background and move statistical modeling forward so that it becomes an organizing principle? Should we teach researchers how to think about statistical analysis as researchers rather than as statisticians? And so once again, watch carefully. You ready? And you see what my perspective is. You see what my choice is. And so those will be the starting points, the frameworks that I'll speak from. A few opinions. First opinion is there's no place in research training for cookbook statistics. Cookbook statistics, as we understand them, are taught all over the place. And I've never wanted to participate or had any sentiment for participating actively in cookbook statistics, the kind of statistics that says, well, if you have two groups and they're independent, then that's a two-group independent t-test. Thank you, now we're done. Or as a student said one time when he showed up and knocked on the door of my office, I'd like to learn multidimensional scaling. I only have 5 minutes or so. I don't need all that theory stuff. If you'll just show me how to do it, that's all I need. And I said, well, I teach a whole course in multidimensional scaling. And he said, yeah, but that's filled with that theory. I just need to know how to run the program. That's what I think we'd like to avoid. All researchers, I would propose, need to know the basics of distribution theory, estimation theory, probability theory, rescaling, robustness, and residuals, and so on, the foundational principles of statistical analysis. But I have another opinion that might be, again, a little bit controversial or arguable. I think researchers don't need to know what math statisticians and programmers know. I think we overteach in some areas. For example, I don't think the sums of squares formulas that I memorized with pleasure. I was in math statistics at the time. When I was an undergraduate student, I memorized those and loved those, but most of the people sitting in my psych stat classes did not appreciate them quite as I did. Degrees of freedom is a hyperdimensional geometric concept. That's a little bit tough to teach at the undergraduate level. Probability density functions and integration, the kinds of things that are mathematical foundational topics, may not be necessary for researchers to master at deep levels. And so I have several relevant desiderata that I would like to propose. First of all, I think that Tukey's principles that emerge from his distinction between EDA and CDA provide a strong orienting philosophical framework that we should use more expansively. They define an a priori set of rules, and they define boundary conditions for actually philosophical and deep thinking about statistical analysis. Those approaches teach researchers to be careful with data, to understand that data are capital, that data are resources to be nurtured and taken care of and properly accounted for. Confirmatory data analysis skills require understanding sampling distributions. And I would propose that we should start, rather than ending as a final little footnote, with resampling theory. I teach resampling theory as the motivation for how we can understand sampling distributions, and then build theoretical sampling distributions off of those, which is, by the way, exactly how Fisher and Gossett both approach the topic. The focus of introductory statistical analysis, I would propose, should be redirected. So instead of teaching how to test hypotheses and starting with an assumption of a hypothesis in which we simply don't believe, I'd rather teach students how to build and evaluate statistical models. And it turns out that that's not all that different, but it is conceptually a rather substantial reframing. And it feeds directly into a graduate quant methods curriculum. So let's examine some of these potential changes that I'm proposing. Let's look at the details of how this might be implemented within a course curriculum or within a textbook. First of all, I love talking to students about the fundamental equation of EDA, that data can be broken into models and error, and it turns out that's more than a fundamental equation for just EDA. It's much more broad than that. This sets the stage for all statistical modeling methods. It sets the stage, for example, for sophisticated graphical scrutiny. If we study pictorial representations, we're actually looking at the model and the error. When we discuss rescaling and standardization, and we do that more deeply than the textbook treatment typically treats it, what we're doing is to move well beyond just how do you construct a z-score. We're moving into a domain where data suddenly can be examined for their content and for their informativeness. If we discuss robust methods, then we set the stage for alternative estimation methods. We focus consideration on the goals of estimation, and we move substantially beyond just the question of whether this particular data point is an outlier or not. When we move on to confirmatory methods and we discuss resampling theory, we build a coherent way to introduce sampling distributions, but we also build a way to focus on the link, the direct link, the explicit link between data and models. When we transform degrees of freedom from hyperdimensional structures in multivariate data spaces, which is what they are, but we can transform them to statistical money, then this, first of all, gives a clean and understandable interpretation of degrees of freedom. It gives an entirely correct interpretation of degrees of freedom. Degrees of freedom are a type of statistical money. It points out that data are themselves exchangeable in the same way that capital, that money, or for that matter, ideas in the marketplace of the academy are exchangeable. And it makes the balance sheet explicit. It means we spend degrees of freedom on useful estimates, but we also save some degrees of freedom for the purpose of testing the fit of the model. And I want to also talk about one of my favorite discussions about how when we take confirmatory formulas that account for competing models, we substantially move the researcher's agenda forward. Researchers think about models of the world. They seldom think about sums of squares or mean squares. And so let me first of all teach this as traditional statisticians would teach it. F is the ratio of two independent mean squares, which are really variance estimates. The first of which is sensitive to treatment effects, the second of which is insensitive to treatment effects. And so those two different estimates of variance will diverge, and the F ratio becomes bigger as the treatment effect takes more and more effect. Wow, that's sort of a mouthful. Or we can talk about the second conceptualization that says that F is the change in fit as we move from one model to a competing model. As you compare one model to another, the fits themselves are fully accounted for in a quantitative way as a difference between our squares. And we trade that off mathematically by putting into the denominator the difference in complexity of those models, the degrees of freedom difference. That seems to me to speak to researchers in a way that's rather deeper than to talk about what Fisher talked about, the ratio of two mean squares. And so the last comment I'll make about the changes, talk about residual analysis. We can carry residual analysis from exploratory into confirmatory domains. Once a model is evaluated, there's still the potential for useful analysis of the residuals. First of all, that's useful for testing assumptions of the model. But second of all, we can look for additional structure in the data to model further. So a few concluding thoughts. These suggestions aren't that radical to people in this room. You guys, some of you have been doing the friendly nodding thing. Partly we're friends and you're nodding your appreciation because we're friends. But I think some of you connect with this. People in this room are selected for having interest in this kind of transition. But I want to propose that they're quite radical in relationship to some undergraduate statistics teaching. Let me mention an exercise I engaged at the Denver APA meetings last summer. I spent about 2 hours going from booth to booth to booth to booth. I looked at maybe 10 or 12 different booths, all of which had statistics textbooks prominently displayed. It's a market kind of process. It's market driven. And I picked up all of the textbooks that I could find that were intro statistical analysis, and I looked at them. And I thought back to McCall 1970, which is what I first taught out of, in 1980 when I taught statistics. And I could see very little difference in the table of contents between those. I probably looked at about 15 or so textbooks with virtually no shift in table of contents from what I first taught out of. There was virtually no mention of Tukey. There's a lot of mention of box plots and stem and leaf diagrams. But Tukey as a philosophical innovator was not even mentioned in any of those textbooks. Very little mention of EDA or CDA as organizing principles. The only purpose of rescaling in those textbooks was to set up z-scores. NHST was the organizing principle in every single one of them without exception. with formulas very explicitly written and defined for when to apply which particular procedure. And as I said, the table of contents were almost identical to 1970s writing. Besides a picture of myself looking a little bit different and perhaps a little bit younger, this is a picture that was taken right around 1980 when I was in graduate school at the University of North Carolina. In 1980, I taught my first undergraduate statistics course, and I dug back through some old notes and I found the syllabus from that course, and you won't be able to see it very well, but if you examine that syllabus and you examine the syllabus that I'm using right this very minute in teaching undergraduate stat, you'd find that my syllabus structure is the same, it's just filled in a little more deeply, which is what Roger Kirk said in a paper he wrote 10 years ago. He proposed actually that the field is radically different for teaching statistics. And then if you read his article, you find out the reason it's different is because every single bullet point has a whole lot more stuff packed into it. But the stuff, the bullet points, were and are the same. These suggestions aren't that radical to people in this room, and it's important to note that some have already started this transition. People like Judd and McClellan, Maxwell and Delaney, Cohen, West and Aiken, and you see pictures of those textbooks. But these are advanced quantitative methods textbooks. They are not undergraduate level texts. You will not find undergraduate level texts who engage this process. We teach out of these texts. Judd and McClellan was one of the very first texts to challenge this. Robert Terry has taught out of Judd and McClellan, and I've always admired his gutsiness in being willing to do that. Maybe 15 years or so ago. They've rewritten it, and it's now coming into fruition. So, if these are good ideas, if what I'm proposing really are good ideas, the question is, why haven't they been implemented? And I have some guesses. I don't have the answers, but I have some guesses. First of all, undergraduate stat textbook writers are not typically quantitative methodologists. The modal person, according to my inspection in Denver last summer, who writes a stat textbook is a stat teacher at a small teaching-oriented university or college somewhere in the United States. What's the overlap with grad textbooks among the quantitative methodologists and those who write graduate textbooks? Well, you've seen them, Maxwell and Delaney, Judd and McClellan, Cohen, West and Aiken. Another reason this situation might exist is it's risky financially. Publishers know that they can sell and market stat textbooks written according to the Fisherian paradigm from the 20s, 30s, and 40s, and the format that you saw in Bob McCall's textbook in the 1970s. So it would be risky financially to try something new. Most undergraduate textbook writers don't write graduate texts. There are a few exceptions, but most of them don't. And so the propagation of the old methods versus the challenge of inventing new methods is substantial. And I use as an example the fact that I still teach out of these textbooks. And a lot of my teaching, even though I have progressive tendencies, a lot of my teaching has not changed as much as I wish it had. There are substantial advantages to revising the undergraduate curriculum. First of all, it reflects the maturing of our discipline. It de-emphasizes computation. It de-emphasizes NHST. It helps to solve some of the recent questionable research practices that we're so focused on at this moment. And fundamentally, ultimately, it emphasizes the importance of developing statistical models of empirical data. That is, I would propose, the focal target to which we should be directing our teaching. And so once more, you see where my orientation is. So from here in Washington, D.C. at APA this summer, I'll give kind of sort of this talk, but substantially expanded. My plan is to present several 3-minute mini lectures to contrast the old, or I should say the current perspective of teaching undergraduate statistics and the newer, more coherent perspective. And so I will look forward to seeing many of you in DC. We're almost out of time. Let's go for about 1 minute or 2 minutes of questions, and then we'll move on with the program for the day. Any questions, comments, discussion, disagreements? It might not be an accident that Leona's talk and my talk are sort of the bookends of the conference. So I'm the good news, she's the more good news. So. Sure. The comment that Leona made was that during her talk at the end of the conference, the last talk in the conference, she'll be discussing who it is that is in the classroom and how we might implement some more progressive approaches to teaching. And so I didn't answer the question, I simply validated the comment and said, we look forward to her talk. Yes, Susanna.
The undergraduate textbook that you would like to have. What haven't you written the textbook you would like
I spent my whole career thinking about writing an undergraduate stat textbook, but I do a lot of quantitative methodology, and so I've been busy training my grad students and publishing papers, and therein lies the challenge. I'd love to write the textbook. I probably won't. I invite others in this room to consider whether you might have the time to be progressive in this way. Thank you. I appreciate that. I'll think about it. I'll talk to my wife about whether I have time in my schedule to. Yeah. I've been teaching my textbook for a long time, and I have an outline, but I doubt I'll have time to write it. Maybe Allie Had, or Mason Garrison, or Patrick O'Keefe, my graduate students here at Vanderbilt, will consider some of these conversations. So.